Now that we've started to make programs that actually change depending on how a user interacts with them, we can start looking at some of the more advanced parts of Java. We're going to start by looking at arrays. So what is an array? Well, very simply, it's a single variable that can hold many different values all at the same time. If you imagine you're writing some software for a checkout clerk in a shop, you can't really create a different variable for every piece of shopping that they are buying. You would need to know exactly how many pieces of shopping they are going to buy in advance, and your code would become very messy and difficult to understand. This is where arrays are useful. Because you can create what's essentially just one variable which has the ability to hold lots of different values. So what do arrays look like and how do we use them? Well, here's an array of the foods from the previous slide. As you can see, it's very similar to a normal variable. The only differences are the addition of the square brackets after the name of the variable, which is how we tell Java that this is an array. And all of the values are inside curly braces, separated by commas. When we're assigning values, we do the exact same things as if we were just assigning it to a normal variable. So if it's a string, you surround the text with quotation marks. If it's an integer, you just type the number, etc. What if we only want to access one specific element in the array though, rather than printing out the entire array? Well, that's easy to do too. All you do is add a square brackets with the position number of the value that you want to access. There is one very small detail that you need to be aware of though. The number system when you're dealing with computers starts with the number 0 and not the number 1. This means that apple is at position 0, orange is at position 1, cereal at position 2 and bacon at position 3. This is just because computers are designed to be as efficient as possible, and the number system that computers use starts with 0 instead of 1, so it wouldn't be efficient to start at 1 for a computer. Back to displaying specific values though. Now that we know how computers count positions in arrays, if we decided we wanted to display the word cereal from our array, we just need to add the number 2 in square brackets to the word foods when we are trying to display the text. In fact, we can treat the value just like any other variable. So if we had an array of numbers, we could add numbers from different indices together just by using the same format. So we could have numbers 3 equals numbers 1 plus numbers 2. They're all their own unique variables in that sense. If you're having trouble visualizing this, you can think of it as a table with just one column. But speaking of tables, what if you wanted to have a second dimension like you would find in most tables? Again, you don't want to create more variables or arrays unnecessarily. You can add another dimension to your array. If we use this table as an example, the list we had previously is now at 00, 01, 02 and 03, and we've added in a column for drinks, lunchtime meals and evening meals. To change your code to be able to do this, you just need to add another set of square brackets when you're defining your array, and then add each of the additional groups, but this time each set of curly braces for each line is going to be separated by commas, and they are all going to be inside another set of curly braces. I normally spread the data out over multiple lines if I'm doing something like this, with each line representing a different column, and that just makes it easier for your code to be read at a later point. And like all white space, it doesn't affect the code in any way. Although we've talked about adding 2 dimensions into an array here, there's no real limit to the number of dimensions. If you wanted to add a 3rd dimension to represent time, that's fine. If you want to add a 4th, 5th, 6th dimensions, you're fine to do that too. You may be wondering why you may want to add more dimensions though. So imagine you had a bunch of folders on your computer. You could consider each folder to be a dimension. Each folder contains a bunch of spreadsheet files, which is another dimension. Within each file you have several worksheets, which is another dimension again. Within each sheet you have cells, which also have rows and columns, and that's 2 more dimensions. You should be aware though that it does become increasingly difficult to try and visualize the more dimensions you add. What if you added the hard drive that the file was located on into our array, and the computer, and the building, and which city it's located in, and which country that city is in. Up to now we have 11 dimensions. Now while it is entirely possible that you would need that level of information, most of the time you won't. And you will naturally find a balancing point where adding more dimensions only adds complexity to your program. I mean, at this point we're basically talking about having 11 parameters just to access a single spreadsheet cell, which is a little over the top.